So before starting, first of all, let me show you the PyTorch. Okay, PyTorch documentation. Guys, if you're looking for any kinds of computer vision related data, you can check this Roboflow Universe platform. So here you will be getting all kinds of computer vision related data, whether it is object detection, image classification, instance segmentation, key point detection, semantic segmentation, all kinds of computer vision related data are available. Even if you see this data, actually this data is already annotated, so you can download the annotation with respect to YOLO 11, YOLO 10, YOLO v9, okay, even TensorFlow, PyTorch, all kinds of format you can save the data. So this is one amazing platform, guys. It has all kinds of computer vision related data, because we know that inside computer vision data annotation is the very costly task, right? So first of all, try to check here if you have the dataset or not. Okay, the dataset you are looking for. So to download the data, just click on that data, and here you will get one option called download project. Just try to click here. After that, you will see an option called download dataset. Okay, now if you don't have the account, please try to sign up with your account. So let me sign up with my account. Okay, after that you will see this option. Now you can select the format, okay, in which format you want to download the data, and simply select this option, download as a zip file. Either you can also download as a code snippet. So you can select this option and click on continue. Okay, so I'll select, I will select YOLO v8. Now if I continue, so it will download the data. Okay, so that's how easily you can download any kinds of computer vision related data from this Roboflow universe. So currently PyTorch is like 2.2 version is you can see. If you want to verify the version, you can go to the PyPy PyTorch PyPy. So here you will see the version, actually the current version. So release history, yeah, so it is 2.2.2. This is the current version. Okay, and how to install this particular PyTorch based on the like machine configuration. Let's say if you're using CPU, GPU, okay, different CUDA version. At a time you can go to the PyTorch official website. Okay, so if I go to the PyTorch, so here they have already given the installation guideline. So see, so here you can select the stable version, that means the current version of the PyTorch, and your operating system you have to also select. Let's say here I'm using Windows machine, so I'll be selecting Windows machine. If you're also using Mac and Linux, so you can use these are the machine as well. Then package by using which package manager you want to install. Either you can go with Conda, either you can go with pip. You can also install with the source and libtorch, but I will suggest go with pip installation. And language wise you have to select. So here I'm going to use Python programming language, so you can select Python. If you are also working in the field of, let's say, C++ and Java, you can also use that particular PyTorch there also. Okay, then CUDA, that means based on your CUDA version, okay, in your system you have to select this particular CUDA version. Let's say if I want to check my CUDA version, so I'll open up my CMD. Okay, if I open up my CMD command prompt, so from here I can check my CUDA version. Okay, so if I just write NVIDIA, okay, NVIDIA hyphen SMI, so it will give me the GPU configuration I'm using in my system, and this is the CUDA version actually I'm using 12.0. Okay, based on that actually you have to select. Now whenever I'm talking about 12.0, that means I will be going with this particular CUDA version. Okay, 12.1. And if you don't have GPU, if you want to install on the CPU, so you can use this particular CPU command, and this is the final command you need to copy and install. But I'm going to use Google Colab for this particular you can say session. uh, because in Google Colab everything would be installed there. I don't need to install anything. But if you want to install, so that's actually you can install. Okay, and let's say if you want to also go with the previous version of the PyTorch, just click here. So it is having, let's say, lots of previous version as well, apart from 2.2. So you can see lots of version are available. Okay, you can also use previous version of the PyTorch. Let's say if you need this PyTorch for any specific project, you want to use, let's say, 2.1.1. okay, at that time you can also install the previous version of the PyTorch. Okay, it is also possible. So that's how they have created one beautiful documentation. So this is the best way to learn actually PyTorch. So everything will get in one place. Let's say you want to learn about the source code and all, so just go to the documentation. Okay, and here they have given everything. Let's say I want to learn about image classification. Okay, so here I can search about image classification. I think it is there. So torch NNN, yeah, so documentation, torch audio, torch vision. Okay, so I need to go with the torch vision. Okay, because vision is a computer vision actually functionality they will provide you. So if I go to the torch vision, now here you can see image classification example is also there. So let me show you. So transform the augmentation image example and training and inference example and tutorial. If I go here, get started with transform v2 illustration, end-to-end object detection segmentation is there, but I want the image classification code. Either you can search here image classification, okay, PyTorch docs. Okay, so it will automatically redirect to that particular page. You can also see, you can also refer this particular tutorial. See, all the tutorials are there, all the source code are there. Okay, you can copy paste from here only and you can try to understand what is happening. But I'll explain each and everything how we can perform the image classification. Okay, and I'll be taking one dataset from the PyTorch only. Okay, the dataset name is fashion MNIST dataset. Okay, so let me show you the fashion MNIST dataset, how it is look like. Fashion MNIST dataset. So this is the dataset, guys. So it has actually fashion related data. So let me show you. So it is having this much of class actually, bag, t-shirt. Okay, then you have shoes. If you have different actually fashion related actually equipment. So this is called actually fashion MNIST dataset. Okay, I'll be using this particular dataset. You can also use your custom data. Okay, I'll tell you how to use the custom data. I will also give you the reference after the session. Okay. And this dataset is already available in the PyTorch. You don't need to download it manually. If you want to also download, this dataset is also available in the Kaggle. Okay, from the Kaggle also you can download. Okay, Kaggle is also having this particular dataset. You can also download from Kaggle. If I go to the all, see, Kaggle is also having fashion MNIST dataset. Okay, you can also get from here. But I'm not going to download because this dataset is already available inside my PyTorch. So from there, actually, I will access my dataset. Okay. Yeah. So first of all, let's open one Collab notebook. Sir, actually, I work on code generation using transformer PyTorch, which work as the retrieval, and I want to trigger the LLM GC with train on this large language intent. You can see like how you can actually do the code generation with the help of that particular model. Okay, just explore over the internet, you will get it. Now here, let me create one notebook. And I'll first of all name this particular notebook image classification using PyTorch. So first of all, I'll be selecting the runtime because I'm going to use GPU here. So make sure you also select the runtime. So let's take the free GPU, T4 GPU I'll be taking, and let's save it. And after that, I will connect this particular node. Okay, it's connected. Now let's first of all test our PyTorch is available or not. So for this, you just need to write import torch. Okay. Now, if it is working, that means it is already there. Yeah, it is already there. Now let's check the version also. So torch dot hyphen version underscore. So now if I show you, see, this is the torch version and CUDA 12.1. Okay, 2.2.1 it is installed, and CUDA they are using 12.1. Okay, that's how we can also check the version of the torch. All right. Okay, now let's start our coding part of the image classification. So first of all, what I will do, I'll import some of the library which is required in this particular project. So let me first of all import all of them. Yeah. So first of all, I already imported torch. I don't need to import. So I'll be importing neural network from the torch. Okay. So from torch. Okay. From torch actually, I'll be importing neural network. Okay. NN. You can check the documentation. I already showed you image classification documentation. They're also importing like that only. See, let me show you. They have also their collab notebook and all. You can download the notebook. Either you can go with the GitHub repo they have shared. And yeah, transform, torch vision. Actually, you need to download these at the you need to import these at the package. Okay, but let's use simple neural network only in this particular series, because I already told you I'll be starting with the very simple concept of the image classification with the help of PyTorch. Then I will also show you the like advanced one. Okay, I'll guide you like on top of the advanced one how it can be done. Okay, so let me import torch nn. Then I need also data loader. Okay, from the PyTorch. So from torch. Okay, it is available in the utils. Okay, dot data. I need something called data loader. Okay, then I also need something called dataset, because I'm going to access the MNIST dataset, fashion MNIST dataset. So it is already available inside torch vision. Okay, torch vision. Okay, import datasets. Okay, then I also need something called some of the, let's say, I mean processing library. Okay, processing package actually. So it is already available inside torch vision. So torch vision, I can copy the name, and here you have something called transform. Okay, transform. I need to import to tensor. Okay, then I also need lambda. Then I need compose. I'll explain whenever I'll be using these at the, let's say, method and all. I'll be explaining what is this to tensor compose. Okay, why I'm using this particular things. Then to showcase my image, actually, I need this matplotlib. So let's import some matplotlib. Okay, matplotlib dot pyplot. Okay, as plt. Okay, so these are the packages as of now I need, and if I need anything else later on, I'll import. Okay, one by one. Okay, it's giving one error. It's telling cannot import lambda from torch vision transform. Okay, so why it's not? Okay, so it should be lambda. Okay, now I think it should work. Yeah, so now it is working. Let me change the view so that you can also see everything. Yeah. What is the lambda used for? I'll tell you whenever I'll be using. Okay, I'll tell you what is the use of lambda. Okay. Yeah. So now what I have to do? First of all, I will load the data. Okay, I'll load my fashion MNIST data. Okay, so this dataset is available inside datasets. So here you need to call fashion. Okay, if you go to the documentation of this particular PyTorch, you will see they are also loading like that only, fashion MNIST. Okay, fashion MNIST. Now inside that you have to provide some of the parameter. Okay, like why you want to download this particular data. So I want to download. Okay, root is equal to. It will create one folder called data. Okay, inside that it will download this particular data. Then after that, I need to specify I want to download the training example. Okay, so train is equal to true. Okay, then I also need to specify I want to download this. Okay, so download is equal to true. Then I want to transform everything to the tensor. Okay, because by default this PyTorch take actually tensor type dataset. Okay, not a numpy. So you have to convert all the, let's say, number to the tensor. Okay, I think you know the tensor. Okay, tensor is a data type. Actually, it supports actually GPU computation. Okay, CUDA computation. So you have to convert everything to the tensor. In TensorFlow also, Keras will take care of this part. Okay, they will directly convert to tensor, but here you have to manually convert it. Okay, to tensor. So for this, here you just need to write transform. Okay, transform is equal to. So here I have already imported this particular to tensor. Okay, so it will automatically convert your number to tensor type data. Okay, now yeah, so this is for my training example. Okay, so here I can write this is my training example. Training underscore data. Okay, similar wise I also need to download my test data. Okay, so here I can write for the testing. So this is my test data. So here root the same directory, but here train is equal to, I need to make it as false because this is my testing example. Okay, download is equal to true, and again I need to convert to tensor. Okay, now if everything is fine, now let me execute this particular code snippet, and let's see whether it is able to download the dataset or not. See, it is downloading the dataset from this particular URL. Okay, now if I go back here in this particular directory, now if I refresh, okay, you will see one data folder has been created. Okay, now if I go inside the data folder, fashion MNIST raw, okay, and inside that, see, it has downloaded all the data. Okay, but it is in binary format. Okay, by default, whenever you are downloading data from the, let's say, Torch Vision, it would be in a binary format. Okay, so this is the format actually they will be downloading. You can't see that particular image, but if you want to load the actual image, you can also get from the Kaggle. I already showed you. Okay, so it's completely fine. I only need the data. I already downloaded this particular data. So here, let me comment out. So download the data. Download data. Okay, data. Now next step, what I have to perform, I got my data. Now I have to define the data loader, because what happens actually, see, in PyTorch actually you have some concept. Okay, so you can't directly actually use the data during training. Okay, so first of all, let's say I downloaded the data. Okay, I download data. Okay, then what I have to do? Okay, I have to create a data loader object. Data loader object. So these are the common steps you have to remember for every project. Okay, you have to create a data loader object. In the data loader object, you have to mention the batch size. Okay, batch size, batch batch size. Okay, like during actually training, how many batches actually will take the data. Okay, and this data loader will help you at that time. It will load the data from the directory you are having. Okay, and it will also define the batch size. Okay, like how many example will come during the training. So that's why data loader is very much important. Okay, so you have to define the data loader. Now let's define the data loader. Okay, I think I already imported this particular method. Okay, data loader. Okay, with the help of this, I will load the data. So now let's define the data loader. So it's like very easy. First of all, define a batch size. Okay, let's take 64. You can take any number. Then I'll call the data loader. Data loader is equal to okay, data loader. Inside that, I need to pass my training example first of all. Training data. Okay. Then I also need to give the batch size. Okay, so batch underscore size. Okay, is equal to batch size. Okay, so then I also need to load for my testing. So this is my training data loader. Okay, so train underscore data loader. Okay, train data loader. I also need to do it for my test data loader. So I'll copy, and here is my test data loader. Okay, so here I'm going to pass my test data. Sorry, here I need to pass, I think. Now I think everything is fine. Now let's load the data loader. Okay, and if you see this particular object, okay, if I print this particular object, so it's a data loader object. Okay, Torch data loader object. You can't see the data. If you want to see the data, so what you have to do, you have to write a for loop. Okay, you have to iterate through this particular data loader, then you will be able to see the data. So for let's say it will give you two things, your x and y. Okay, in, let's say, test data loader. Okay, now if I print my x and y, see, this is the data actually I'll get. Okay, x means this is the image, that means your image pixel. Okay, and y means this is the label, like whether it's a let's say these are the, actually I already showed you, I think, fashion MNIST classes. So it is having this many of classes. Okay, 10 classes: t-shirt, trouser, then pullover, dress, coat, sandal, then shirt, sneaker, bag, and ankle boot. Okay, now see, whenever it is coming 0, 1, 2, that means this is the label. Okay, label of this particular class. Now whenever you can see the 0, okay, if I show you, whenever you can see the 0, let's say I will only print the y. See, I'll only print the y. So whenever you can see the 0, okay, that means this is a t-shirt. Okay, this is a t-shirt. Okay, that's how actually it is aligned with the label. So let me go back. Just a minute. Let me go back. Yeah. Now we can see all the matrices. Okay. So that's how actually, and see, the data type is a tensor data type. It's not a numpy array. It's not a simple numpy array. This is a tensor data type. Okay. Now we are able to do the data loader part. Now we are able to load the data. Okay, in a batches. Now what I have to perform? I have to write one condition. Okay, because see, sometimes what will happen? Sometimes actually you will get some of the issue. Let's say you have used the limit of the GPU. At that time, actually, you will get the CPU. But that time, actually, if you mention the GPU training, that means CUDA, it will throw error. Okay, so for this, I can automate this process. So in PyTorch, actually, there is a logic actually you have to write. So if I just write device, okay, device is equal to, so CUDA, okay, if, okay, if torch dot CUDA is available, okay, is underscore available, available, okay, otherwise set CPU, else, okay, else you have to set CPU, okay, sorry, CPU, it should be CPU. Yeah. Now see what will happen if I print the device right now. It will give me CUDA because I already selected the GPU. See, it will give me CUDA because torch is automatically checking whether I'm having this CUDA enable or not. That means GPU enable or not, because I already showed you I selected already GPU, T4 GPU. But if you select to GPU right now, you will see it will print CPU. That's how it can automatically detect your device, okay, and it can like automatically set during training, like where you want to train this particular model, whether in CPU or whether in GPU machine. Okay, so that's how you don't need to change the code, only you just need to write this particular statement and everything would be automatically done, okay, inside the PyTorch. Now what I have to do, I'll define my neural network. Okay, I'll define my neural network. So let's define our custom, okay, NN, okay, or model. I can write model. Okay, so here I'll just write one class for neural network, neural, okay, neural networks. So in PyTorch, actually, you have to write this thing manually. Okay, so that's why I already told you PyTorch is a little bit low level language. If you understand Python object oriented programming, so definitely it should be clear. Then I think you remember we already imported this NN, okay, neural network. So I have to inherit, okay, from this particular NN module. So that's how I'll be inheriting. Okay, inheriting. So whenever you do inheriting, I think you remember you have to also define the constructor inside that. So underscore init, underscore, and here I have to define the self. Okay, then inside that I'll be writing one super class. Okay, I think you know what is super class. Whenever you perform inheriting, okay, inheritance, you already know what is super class. So I want to inherit from this neural network, and here I just need to write self. Okay, so all the functionality actually I will get from my NN module. Okay, I want to access, so that's why I'm just writing this super class. So it should be underscore init, underscore, yeah, close. Now super class is ready. Now I will be adding the flatten layers of self dot flatten. Okay, so here on the NN itself I will get the flatten layer. Okay, so flatten. Okay, after that I'll be adding my linear, okay, linear stack. That means my how many, let's say, neural network I'll be taking and what is the activation function I'm taking. Okay, so for this I already created this particular architecture. Let me show you. So see, this is the architecture I already created. So this is my sorry, so this is my linear ReLU stack. Okay, so here what I have done, here I have taken one sequential layer. Okay, I think you already saw in the Keras also I was taking sequential layer because it's a sequential model. Okay, it will go to the sequence to sequence will go. So first of all, I'm taking one linear layer. Okay, and it is having 28 cross 28 cross. Okay, this is the image dimension. Okay, because if you check this particular fashion MNIST, the image dimension is 28 cross 28 cross matrix. Okay, so based on the image resolution, you have to provide this particular input size. Okay, then you have to define the like you can say neurons. Okay, how many neurons you want to take in this particular linear layer? Okay, so I want to take 512 neurons. Then after take, I have taken one ReLU activation function. Then again I took the, like you can say, one linear layer, and inside that I'm taking an again, like you can say, see, this is the input. Like after going to this particular layer, it will return this particular input. So this should be the input. And again, I'm defining the output neurons. That means 512. Again, I'm taking one activation function, relay activation function. Again, I'm passing this particular input to this particular layer. Okay. Then how many output actually we are having in this particular example? 10 example. Okay. As I already showed you, level is equal to 10. 10 different level actually we are having. But yesterday I was using only 2 level. Okay. Cat and dog. But here I'm having 10 level. That's why at the last layer, actually I've just defined 10 neurons. Okay. That means it will give you 10 output. Okay. So that's how actually you can define a custom architecture. Okay. With the help of PyTorch. And now see, everything you have written as a low level coding here. So here I'm not using any kinds of class and method. Everything you have to write as a low level. That's why PyTorch is like, it is most used in the research field, because in the research you have the customization option. Okay, you can customize your architecture, you can customize anything. So whenever you are doing anything research for let's say research work and all, if you're getting your own architecture and all, go with the PyTorch implementation. Otherwise, if you're developing something, okay, you can go with the TensorFlow implementation. Okay, both you can use, both actually it is mostly used in the industry, but it's up to you which framework actually you will be choosing. Okay, personally, let's say I may prefer, let's say, Keras. You may prefer, let's say, PyTorch. Okay, it's up to you. Okay, it's developer to developer choice which particular framework they'll be using for the specific task. Okay, both I'm showing you now. Just try to decide whatever actually we'll be using. Okay, now let's say you want to use the custom pre-10 architecture. Okay, let's say you want to use the pre-10 architecture. At the time that you can search ResNet, or let's say VG16. Okay, yesterday I was also VG16 in PyTorch. Okay, so if you just search over internet, okay, you will see that particular code, how to load this particular VG16. Okay, so here is the code they have already given. Weight is equal to VG16. I want the example code. Main model pre-10 weights. Okay, data loader. VG16 optional non-parameters. So yeah, you have to import like that. Torch Vision model VG16 base. Okay, you have to import like that. And these are some parameter you have to give the input. Okay, in the next phase, I think they have already given the tutorial. Okay, you can directly also search the tutorial like VG16 notebook. You will also get it. Okay, from there you can also copy paste the code. Classification, the last layer in the LLM, and activation function. Sir, have you used the linear activation for the classification in the last layer? Here you're talking about at the last layer. No, last layer actually I haven't taken any activation function. Okay, because I want like 10 probabilities. Okay, that's why I haven't taken any activation function in the last layer. You can also add softmax. You can either like remove the softmax, both will work. Okay, now let's define the architecture. Let me define again. Yeah. Then here you have to also write another function called forward. Okay, because in the forward, actually what you will do, you will do the forward propagation. Okay, so for this actually you need this particular forward. Okay, this forward. So here you will give the X data. It will first of all like pass into the neural network actually you have developed. Okay, this flatten. Then linear logic stack actually you have developed. It will go inside that. Then it will give you this particular output. Okay, so this is called forward pass. Okay, forward pass you have to write. And if you check the documentation, so here is the documentation. They have also written the forward pass. Okay, here let me show you. See, okay, they have also written the forward pass. That's how we have to define the neural network. Okay, inside the PyTorch. All right. So everything you don't need to remember. Everything is available in the documentation. So try to get the code from here. You don't need to remember anything because it's not possible to remember everything, right? Yeah. So it's just a like template kinds of code I'll be creating. So later on, you just change the data and you can use this particular code. Okay, that's how we can use it. Done. Now what I have to do, I have to load this particular neural network to my device. Okay, the device actually I got. So if I show you my device, I'm inside CUDA. Okay, I'm inside CUDA. That means I'm using GPU. Okay, so let's load my model inside the GPU. So to load it, first of all, you just need to write model is equal to the neural network you have created, this particular class. Let me define this particular object. Okay, and you have to load two device. Okay, two, and here you just need to give the device because it will load everything inside the GPU because I want to perform GPU training. Okay, now if I print my model, okay, if I print my model, you will see this is my model architecture. Okay, this is my model architecture, entire model architecture. Okay, yeah. Now what I have to do, I have to define my loss function because yesterday also I was defining my loss function, then optimizer, right? So here also you need to define the loss function and optimizer. So how to define? Just write loss function. So loss underscore fn, that means function. So I'll be using something called nn dot cross entropy loss. Okay, there is a loss called cross entropy. Okay, cross entropy loss. This is the loss function I'm going to use. And optimizer wise, so let me just write optimizer. Okay, optimizer is equal to, I'm going to use torch dot optim, okay, dot stochastic gradient descent. Okay, SGD, stochastic gradient descent. So this is the loss function I'm going to use. And here you just need to give the model parameter, the model you have developed. Okay, this model parameter you have to pass because stochastic gradient descent will take the parameter and it will do the back propagation, right? It will update the weights. For this, you have to give the weight, all the weights you have defined, parameters. Okay, then here you have to pass the learning rate. So LR is equal to, so I can give the learning rate like that. So 1e, okay, minus 3. So this will give you one number. So let me show you this particular number you can provide. So this is the number 0.001. Okay, you can write this particular 0.001 like that, 1e minus e. Okay, that's how you can write. You can also write like that. You can also write like that. Okay, both you can mention. Okay, now let's load the loss function and optimize it. Okay, then here, first of all, what you have to do, you have to write one training loop. Okay, you have to write one training loop. So let me just write train loop. Inside PyTorch, you have to write one train loop. So if I show you the documentation also, they have also written the training loop. After neural network optimizer, see, this is the training loop. Train the neural network. For this, you have to write one training loop. Okay, and for like testing also, you have to write one testing loop. Okay, see, this is the testing loop. That's how you can write different loop. Okay, and this should be the custom loop. Okay, you can't use any kinds of functionality from the PyTorch. Okay, there is no class and method. It will automatically perform your training and let's say testing. You have to write this particular loop by your own. Okay, now I have already written this particular training loop. Let me show you how it will look like. So this is the common code for every, let's say, PyTorch implementation. So you can use it. So this is my training loop. Okay, so here I have named this particular function as train. It will take the data loader. That means the data actually you have loaded for the training. It will also take the model actually you have developed, the model architecture you have developed. Then the loss function you have created, and the optimizer. Okay, and first of all, it will check the size of the data. Okay, then after that, it will tell the model I want to train the model. Okay, that's why I'm just writing model.train. After that, I'm just taking the batches. Okay, that means the data. I think I already showed you, if you just perform for loop on top of the data, it will give you this particular data. That means the tensor. Okay, tensor value. This is what actually I'm loading. It will give you the image and it will give you the label. Okay, after that, I'm loading to the device. That means in the CUDA. After that, what I'm doing, I'm predicting on top of my model. Model will give me some losses. That losses actually I'm performing back propagation. Okay, so this is the back propagation code. So here I'm using optimizer, loss.backward, optimizer the step. That means it will calculate the loss. Okay, so what is happening here? So here you are giving, let's say this is your input data. This is your input data. Okay, so you are giving this particular input data to the model. Let's say this is my model. Okay, you are giving this particular input data to the model. So model will predict something, that means y hat. Okay, based on that, actually it will calculate the loss. Okay, loss. Okay, we'll get some loss. Based on the loss, actually what he will do, okay, based on the loss, you will come here to the model parameter. Okay, you will update the weight. Okay, we'll update the weight, and that's called backward parameter. Sorry, backward like pass, we call it as back propagation. Okay, you are doing something called back propagation. So that is what actually it is happening. So if you check here, first of all, I'm predicting something, it will give me the y hat, that means the prediction. I'm calculating the loss. Based on the loss, actually I'm doing the backward, that means I'm doing the backward propagation. Okay, backward propagation. Okay, back propagation technique. So here I've already commented out. So once it is done, I'm also like printing the loss after 10 epoch. Okay, after 10 epoch, or let's say after 10 steps, okay, I'm printing this particular loss, and the accuracy actually I'm getting from my model itself. Okay, and this is the logic to write. So if you check the documentation, they have also written like that only. So here is the for yeah, so here is the code. Okay, they have also written like that only. So you have to also written like that. Okay, now let's define my training loop. So this is my training loop. Now you can understand like how the things is working inside the keras. Okay, I think in the keras actually I directly use that particular, let's say, model sequential layer. Okay, after that model.fit I was doing, right? But how everything is working in the backend? Okay, they have also written the code like that only. Okay, everything they have written in a Python code. Okay, they are also using, let's say, low level TensorFlow in the backend whenever I'm talking about keras, and they're handling in that way. Okay, so if you want to understand the Keras API, how the things are working, so you can understand this particular PyTorch code and you will be automatically get the idea how the things are working. Okay, this is the idea. Okay, so similar wise, you have to mention for the testing loop. Okay, so let's say I want to also test my data on my model. So here is the testing loop I can use. Okay, this is the testing loop. Since a testing loop, I'm not doing anything. Again, I'm taking the data loader model and loss function, checking the size, getting the basis. Okay, then I'm just doing the model.evaluation because I want to perform the evaluation. Then here, if you see here, I'm just predicting. Okay, then I'm just like just updating the test loss and the correct. That means the accuracy. And here I'm just printing one by one. And the same thing they are also suggesting in the documentation. Let me show you. Same thing they are also suggesting in the documentation. So here, if I show you the testing example, yeah, so they are doing the same thing only. Okay, if you check here, testing code. Okay, they are doing the same thing only. Yeah, I'll provide the code in the resources section. Okay, we'll get it from that particular dashboard. Okay, otherwise what I can do right now, I can also share this particular notebook link in the chat. And everything will get from the dashboard itself. Okay, the dashboard actually I showed you, computer vision hands-on. Please make sure you have enrolled for this particular course. And this is completely free. Okay, this is a community program. So this is the notebook link, guys. You can refer. Okay. Now let me also define the test loop. Yeah. So finally, I can start the training. So let's start the training. Start training. Okay, to start the training, first of all, I need to define the epoch. Okay, number of epochs you want to train. So let's train 10 epoch only. Okay. 10 epoch is not like very good epoch. You can set like higher epoch whenever you are training your actual model. Okay, I'm just showing you. That's why I've just set 10 epoch. And now I'll just start the training. So for 14 range. Okay, and inside that I'll process the epochs. Okay, then I'll print the epoch also. So let's print the epoch so that I can track my epoch, how many epoch is going on and all. Okay, then after that I'll call my training loop. Okay, so train, inside that I'm calling this particular function called train. It will take the data loader model, loss function and optimizer. Let's pass one by one. So first of all, it will take the train data loader, train underscore data loader. Okay, then it will also take the model you have developed. It will also take the loss function, loss fn. Okay, it will also take the optimizer. So optimizer, optimizer. Okay, then I will also define for my test loop. Test loop. So here I need to write test loop. So it should be test loader. So it will take the model and loss function optimizer. I don't need to give because I don't need to perform the back propagation during testing. Okay. Now once it is done, it will also print a done. Okay. Once training is done, it will print done. It will print done. Now let me start the training and let me see how things are working. Now see, this is the loss, and every epoch actually loss is decreasing. Okay, you can see loss is decreasing. That means my model is learning. Now epoch 2 is going on, because in one epoch actually it is performing that many of step. Okay, this is called step per epoch, and I have defined 10 epoch. Okay, so it will complete till 10 epoch, and every epoch if you see loss is decreasing. And once this 3 epoch is done, it will show you the accuracy, final accuracy. So 61% accuracy, and average loss you got 1.49. Okay, again you can see 63% accuracy, 64% accuracy. So loss should be close to 0. Okay, then your model would be good. 65% accuracy. Okay, so 10 epoch is going on, and loss is close to 0 right now. Still it will learn, so you can increase the epoch to 20. Okay, you will see more accuracy will get. I got 70.7% accuracy. Average loss is 0.78. Okay, and my execution is done. Okay, that's how we can perform the training. Now what I have to do, training is completed. Now I can save this particular model. Okay, so how to save the model? So save. Okay, save model. To save the model, just write torch dot save. Okay, and here you just need to write model dot state dict. Okay, state dict. Okay, you have to save this particular model in a state dict format, and you have to give the name. Okay, name of the model. So I want to save as a model dot pth. Okay, that means PyTorch model. Pth is a PyTorch format. Okay, pth. Then once this saved, I will also print this model is saved. Model saved. Okay, model saved. Now let me also save this model. Now if I refresh, see model would be there. Now model is saved. Okay. Now if you want to load this particular model, how to load it? So it's like very simple, load model. So for this you have to first of all define the architecture. So model is equal to neural network. The neural network we have created. Okay. Then after that I need to load this particular model. So model dot load state load underscore state dict underscore state underscore dict. Okay, state dict. So here you just need to write torch. Okay, dot load, and I need to give the name of the model. So this is the model name. So copy path, and here I can define. Okay, so model dot pth. You can also give the name of the model. It will work. Yeah. So that's how I can load the model. Now see, all key match successfully. That means you have successfully loaded the model. Okay. Then now what I will do, I'll define my prediction classes. Okay, all the prediction classes actually I'm having. So prediction classes. So where you will get this particular prediction classes? From the Kaggle, I think I already showed you. So if I go to the Kaggle, so these are my prediction classes. I'll copy one by one, and here I'll try to arrange everything. Okay, so here I'm going to create a classes list, because my model will give me actually number. Okay, that number I need to map. Okay, map with this particular category, and I want to return the category. That's why I'm just defining one classes. Okay, classes list. Inside the list, first of all, I will define t-shirt and top. So because it is coming at the 0 index, okay, that's why I'm keeping at the 0 index. Okay, and after that I need to keep this particular trouser. This is in 1 index. Okay, that's how you have to align the index. Then coming pullover. Okay, then coming dresses. Okay, then I think after dresses, coat is coming. Okay, after coat, sandal is coming. Then after sandal, shirt is coming. Then after shirt, sneaker is coming. Then after sneaker, bag is coming. Then after bag, this ankle boot is also coming. Okay, so these are the classes. Now I can delete everything. Okay, now if I execute and check the length of this particular classes, you'll see it's a 10 classes only. So it should be classes. 10 classes, okay, we are having in this particular example. Now what I will do, I'll just write the prediction code, okay, but before that I just need to do the model.eval. I want to perform the evaluation. Okay, then what I will do, I'll first of all take one test data. Okay, so let's take one test data. So I'll load this particular test data, so it is available inside my test data, test underscore data. Okay, I'll take the first example, so 0 0. Okay, now if I show you this particular x, so this is my image. Okay, this is my image. Okay, this is my image. Custom it, yeah. Now I also need the label. Okay, like the actual label of this particular image. So here I can store it in the y, and this thing I can load from here. So test data. Okay, I will take the label. Okay, label, it is available inside one index. Okay, now if I also print the y, I think you can also see the y. Okay, y is also there, I think, somewhere. Let's only print the y. See. Okay, y is 9. 9 means it's a ankle boot. Okay, so here I've already defined it's ankle boot 9. If you see index 9, it's ankle boot. Okay, let's see whether my model is able to predict ankle boot or not. Okay. Okay, so if it is ankle boot, if it is predicting perfectly, that means my model has learned. Okay, because I got more than 70% accuracy. Okay, so it should predict correctly. So let's test it. So what I can do right now, I'll be using the model. So first of all, you have to write with torch, because I don't want to perform gradient. Okay, on top of this particular prediction code. So that's why you need to define no grad, no underscore grad, no gradient. Okay, I don't want to perform any gradient operation. And inside that I have my model, and I'll pass my x data. And this model will give me prediction. So pred, I'll store it. Then after that, what I have to do, I have to map with the classes. Okay, the classes actually I have developed. Okay, let's say after prediction, this model will return the number. Okay, that number I need to map with the classes. Okay, how to do it? So that is how actually you can do it. Let me show you. Yeah, so here I already written. So whatever prediction actually I'm getting, I'm doing the argmax, because it will give me the probability score. Okay, I think you remember in the softmax activation function, it will give you the probability score. That's probability score actually I'm doing the argmax. It will give me the number right now. Okay, let's say it's a 0, 1 or 2 or 9. So this particular number I'll map with the classes actually have developed. Now let's say if your model is let's say predicting 9. Okay, so if your model is predicting 9, so if I pass 9 in the classes, so what will happen? Okay, if I pass 9 in the classes, so it will print ankle boot. So it will print ankle boot. Okay, let's say your model is giving 8, so it will give me bag. That's how it will give me the index. Okay, that index actually I'm just mapping with this particular classes, and it will give you that particular value. Okay, from the list itself. That is what actually I'm doing here. Okay, then after that, I'm just also printing my actual prediction and the correct prediction. That means the prediction I got from my model. Okay, so both actually I'm printing one by one. Now let's see whether it is able to predict or not. So if I execute, now see, predicted ankle boot actually is also ankle boot. That means my model is predicting perfectly, because as I already showed you, the data actually I loaded here, testing data, it is 9. That means it's an ankle boot, and your model is also predicting ankle boot. Okay, that is 9. That means this model is working fine. Okay. Yeah. Now, if you want to visualize all the images, so you can also do it. So let me show you. So this is the code. With the help of matplotlib, we can visualize some sample of the images. Okay, like how it will look like. See. So this is the ankle boot. This is the level 0. That means t-shirt. Then I don't know. I think this is a top. Then no, not this is a top. I think it's a what it can be. It's a dress, coat, sandal, trouser. Maybe it's a dress, I think, mostly. Okay, then shoes we are having. Yeah, so that's actually you can visualize the image, and these images are actually BGB. You can say grayscale image. That's why it's looking like that. Okay, it's a one channel image. We can also work with color image. Okay, now let me also give you the guidance, like where you can learn the custom data, that means color image, okay, as well with the pre-trained model. So for this actually you can refer Kaggle. Okay, so Kaggle is having different data. So let's say if I search for cat dog, okay, cat dog classification, okay, using PyTorch, Kaggle. So Kaggle is having lots of notebooks, so you can refer this particular notebook. So cat dog classification with PyTorch. If I open it up, so they have different notebook actually, and they are working with this cat dog example. The example I showed you, okay, yesterday. Now see guys, they're also loading the torch, setting the device. After that, loading the image, okay, cat.image. Then they are define the directory of the image. Then they are printing some of the image, okay, like how this images look like. After that, they are resizing the image, okay, as you can see. Then they are defining the this one data transformation, because yesterday I was also telling about data transformation. You have to perform some augmentation, then resizing this particular image, okay, with respect to the model input you will be having. So everything they are performing here, and they are also loading the data loader. Okay, so as you can see, they are also performing the data loader to load the example. Okay, see data loader. But before performing the data loader, you have to load the data from the folder. Okay, the folder actually you are having. So for this, you have to use this dataset.image folder, and here you have to give the directory, like where you have this particular image. After that, you will be loading. Then what you have to do, we have to define all the classes name and all. Then this is the final tensor actually will get. Okay, and if you want to visualize, you can also visualize. Now you have to define the data loader. Okay, with the batch size. Okay, with the batch size, you have to load it. Then after that, they will be defining the model architecture. After performing compose and loading the image, data loader. Now they are getting the CNN classifier. Okay, and this is the CNN architecture they have developed. Okay, this is the custom architecture they are using. But you can also search for, let's say I want to use pre-trained model, let's say VG16 or let's say ResNet 15. You can search over Kaggle, you will get that particular notebook also. Okay, that's how you can learn different notebook you can explore and you can learn. Okay, then after that they are training the same thing. They return the training loop and testing loop. Okay, see this is the training loop and this is the testing loop. Okay, the way actually I have written. Then after that they are doing the epoch. Okay, training the model. Then after that they are testing the model also. Okay, then plot the graphs and all, like how many accuracy they are getting and all, the losses and all. Then after that, they are taking one image and doing the prediction. Okay, doing the prediction. So if you just go through this particular example, you will get each and every idea how the things are working. So what I will do, I'll add this particular notebook link in the notebook I have shared with you, so that you can get a reference later on. With custom data. So Kaggle is the best platform to explore, guys. So not only this particular notebook. So if I go back, it is having so many notebook. Okay, if I go to the data, cat dog classification, PyTorch, it is having lots of notebook experiment. Let me show you dataset. Cat dog. Not only cat dog, you can take any kinds of data, no issue. Cat and dog. If I go to the codes, here you can search PyTorch implementation. Okay, see PyTorch cat and dog classification with ResNet 50. Okay, see this is the transfer learning approach. Okay, you can refer. Now if I open this particular notebook, now see The same step they are performing as I already showed you, but when they're loading the model, they're using ResNet 50C. That's how you have to load the model. Models dot ResNet 50 pre10 is equal to two device you have to load. Then after that, you have to define the params is equal to gradient false because you want to take the custom architecture. Yesterday I was discussing, I think. So you'll be dropping this particular dense layer and you will be freezing these at the weight. Okay, that means the convolutional layer weights you will be freezing. Okay, so that's how actually they are doing in the ResNet 50. Then the training loop, after that the testing loop, and the training is happening. Okay, then confusion matrix and all. Yeah, so I can also give you this particular notebook reference so that you can learn the pre-10 model also. Okay, now guys, if you have any query, you can ask me. And next class actually will be exploring this thing actually. Next class I think mostly will be start with the object detection. Okay, because image classification wise I think you got the idea. Okay, how to perform image classification and all, right, with the help of PyTorch as well as the TensorFlow, both I have showed you. Okay, now you can use any of them and you can decide which framework you'll be using. If you're using PyTorch implementation, you have to understand the low level programming. If you want to use, let's say, Keras, everything is at a high level, you have to import and use it. So which is like more easier to you guys to understand? Let me know. If you have attended my previous session, maybe you can compare. Okay, which code is like more suitable for you? Okay. Okay, so please try to practice. Okay, once you practice from your side, everything would be clear. And the reference actually I have given you. Try to also go with this particular notebook and try to understand how we can create the custom architecture, CNN architecture, either how we can load the pre-trained model. Okay, both I have showed you. Yeah. Yeah, both are equally approachable, but again, it's your choice which one you'll be using whenever you are implementing any kinds of projects. Okay. Yeah.